The global technology sector produces a waste stream of millions of functional devices discarded every year, largely due to internal failures that cannot be repaired. Electrochemical battery degradation is the primary bottleneck to device longevity. When a sealed battery fails, the entire product is typically discarded, regardless of whether the other internal components still function. To address this, the European Union adopted Battery Regulation 2023/1542. Article 11 specifically targets the physical design of consumer hardware. By February 18, 2027, the law requires that all portable batteries in consumer appliances must be readily removable and replaceable by the end user. This regulation dictates a structural revision of global hardware engineering standards, moving past simple environmental recycling guidelines to force a change in how devices are built. Modern hardware engineering relies on permanently sealed, adhesively bonded chassis to achieve the ultra-thin and waterproof designs that consumers currently demand. Transitioning back to the modular battery doors used in the early 2000s would require manufacturers to sacrifice internal volume and structural integrity. Rather than a uniform design regression, manufacturers are navigating a dual-track compliance choice to meet the new legal standards. There are two distinct legal paths. Manufacturers can either physically redesign hardware for user modularity or engineer for specific electrochemical durability metrics to bypass the removability requirement. This choice bifurcates the global hardware market, driven largely by product profit margins and technical feasibility. For devices on the modularity pathway, battery extraction must be possible using only commercially available tools. The European Commission bans the use of proprietary screwdrivers or instruments unless the manufacturer includes them for free inside the retail packaging. Beyond physical fasteners, the mandate dictates a shift in software architecture, the legally binding eradication of parts pairing in power management systems. Parts pairing uses software serialization to bind a battery to a specific logic board. Historically, a serial number mismatch from a third-party battery would restrict performance. Now, device architectures must natively accept compatible third-party batteries without artificial software hindrances or functional degradation. Manufacturers may still display a notification informing the user that a non-original battery is in use, but they cannot block core device functions. By decoupling hardware security from these software locks, the regulation challenges the repair monopolies previously held by major technology conglomerates. Maintaining high levels of integration is critical for micro-wearables and high-performance laptops where internal space is at a premium. Traditional industrial glues are no longer viable for these designs, as they cannot be removed with heat guns, prying force, or chemical solvents, all of which are now restricted. To solve this, the industry is adopting debonding on-demand technologies, specifically electroadhesion tape. This material functions like a traditional industrial adhesive, providing shock resistance and structural rigidity during normal consumer use. To remove the battery, a technician applies a low-voltage direct current, between 9 and 12 volts, to conductive tabs on the tape. Applying this current for approximately 60 seconds triggers a reaction that neutralizes the polymer bond at a molecular level. The battery can then be lifted out without prying or the risk of puncturing the cell, leaving the internal frame clean. This engineering solution satisfies the legal requirement for non-destructive battery extraction using common, commercially available electrical tools. Premium manufacturers can maintain permanently sealed designs by following the secondary compliance pathway found in the Eco-Design Regulation. Regulation EU 2023-1670 allows manufacturers to restrict battery replacement to professionals if the device meets specific durability thresholds. To qualify, the battery must endure 1,000 full charging cycles while retaining at least 80. These water resistance standards rely on fully sealed architectures, creating a direct conflict with user-removable physical designs. This results in an engineering split. High-margin flagships will focus on extreme chemical longevity to remain sealed, while mid-tier devices will adopt modular physical frames. Moving beyond physical engineering, the mandate requires a restructuring of global supply chain and inventory dynamics. Manufacturers must now guarantee that replacement batteries are available for at least 5 years after a product is removed from the market. This forces companies to maintain long-term warehouses for chemically active lithium-ion inventory, a significant change in how electronic components are managed. In April 2026, the European Commission introduced draft delegated acts to address the physical limits of miniaturization. These derogations provide relief for smartwatches and medical devices, where spatial constraints make end-user replacement impossible without compromising safety. The final compliance hurdle is the digital battery passport, which becomes a requirement in 2027. Every battery must feature a link to a document tracking its carbon footprint, the ethical sourcing of its minerals, and its entire life cycle data. Failure to trace these historically opaque supply chains turns sustainability metrics into a non-negotiable barrier for European market access. These regulations are part of a strategy to manage a global battery demand that is projected to increase 14-fold by 2030. To meet that demand, the EU is mandating designs that allow for the safe extraction and recycling of cobalt, lithium, and indium. This requirement also applies to light means of transport, ensuring that the high-capacity batteries in e-bikes and scooters can be safely maintained. Maintaining separate production lines for modular and sealed devices is a massive logistical and financial burden. This leads to the Brussels effect, where companies alter their global hardware designs to meet Europe's strict standards for the sake of manufacturing efficiency. By leveraging its 17% share of global battery capacity, the European Union is using Article 11 to challenge the industry's reliance on permanently sealed, disposable designs. This regulatory pressure is forcing a transition toward compliant architectures that are now being distributed to markets worldwide. The 2027 mandate avoids forcing a regression to low-quality components, instead acting as a catalyst for chemical longevity and new materials like electroadhesion tape. Through the economic influence of its market, the EU battery regulation is establishing a new baseline for how consumer electronics are designed and maintained across the globe.